Did you get it? Okay, let's begin. Dear Heavenly Father, we thank you again for this opportunity we have to meet together and talk about your creation. I thank you, Lord, for these students. Pray, Lord, that you'd just bless this class, Lord. We thank you that you loved us even when we didn't. Even when we don't love you, you still love us, Lord Jesus. And we thank you for that. I just pray you begin to be with us and help us to glorify you in what we do this day, Lord. In your name I pray. Amen. So, maybe you guys got questions for me. Oh, I was going to ask one. I have one question. And this is not at all attached to the ending class early or not. I mean, we would still end class early, but suppose we answer all your questions and we still got a little bit of time left over. Would it be okay if I covered a little bit of the material past the test? Show of hands, people who would be bothered by this. I have, in the yellow, you said you'd be bothered by this. You should raise your hand. Okay, there you go. So I have one. Oh. It'd be confusing. All right, I won't do it then. I won't do it.
The test is next Thursday.
Yeah, the test is next Thursday. That's true. Okay, so what's your questions then, guys? Who's the first person with a question here? Yep.
Homework number 14, problem 3.
Homework 14, problem 3. Alrighty. I'll work my problem, which is probably very similar to yours. All right. We're asked to integrate x to the fourth times the exponential of x to the fifth minus 6 dx. Now, sometimes I like to use the following notation for this instead. This is x to the fourth times the exponential of x to the fifth minus 6. I like this notation sometimes better because I can clearly see what the exponential, like the argument of the exponential is, And I'm not tempted to think, you get confused by, superscript versus not superscript notation or whatever. So is this the one we're talking about? Okay. So guys, what should I try to do here? Make a substitution, right? So let's let u equal to, how about x to the fifth minus 6? I think that's going to work, right? Now, did you try that? Oh, you tried that. Okay, so, So du is 5x to the fourth dx, right? So if we solve for dx, what do we have? We have dx is equal to du divided by 5x to the fourth, right? So I take these ideas and I plug them in. I have x to the fourth times the exponential of u. Dx was what? Dx was du over 5x to the fourth. So the x to the fourths do what? They cancel, right? And we're left with 1/5 the integral of the exponential of u to u. Of course, I mean, you could rewrite this just this if you want to do this. I mean, whatever notation you're more comfortable with, I don't really care. Anyway, so what's the answer? Then we can integrate that, right? What does it give us? The integral of the exponential is the exponential, so I get e to the u plus a constant, right? And so that's 1/5 e to the... Let me stop being stupid. I know some of you are just going to copy these steps down without thinking. Let me make them better. 1/5 exponential of u plus a constant, right? And that is 1/5 exponential of x to the fifth minus 6 plus a constant. Now, is that what you got? So what do you think the hang-up was?
Actually, no, that is what I got, I think. After I comes.
Yeah. Was your question? So exponential of u is just another notation for e to the u, right? So the integral of the exponential of u du is just the exponential of u plus a constant again, all right? This is just a different notation. Last time I... Well, that's because there's a 5 here, right? And so that and that cancel, and I pull the 1/5 out of the integral, and it's just multiplying 1/5. Uh-huh.
Why don't you
Yeah.
substitute in the 5x before dx, or du? Instead you just do plus d.
I'm sorry?
Like in the second step. Where
Are you asking why I didn't do like this? Or no?
for du, wouldn't you put in 5x to the 4th dx?
Well, that would be like putting on your shoes and then taking them off again, and then asking why your shoes weren't on.
Oh, wait, okay.
That was helpful?
No, that actually, I wouldn't.
Okay. You weren't listening to me. That's the first step in understanding is not listening to me. Yes, understand. All this substitution is.
Yeah.
So that dx is just dx is that.
Okay, yeah, now I see.
Yeah. I mean, if it's a good U substitution, after we make it, the x's should cancel out, right?
Yeah.
Excuse me. That's coming. Sorry, there's an additional danger for sitting in the front row today. Okay, so is there another question? There must be. Yes. Number 7. That was number 3. Yeah, okay. Number 7, we have integral of x e to the minus x squared plus e to the x over e to the x plus 2 dx. Ugh. So first of all, divide and conquer, all right? I mean, break it into 2 pieces. We have first the integral of x e to the minus x squared dx plus the integral of e to the x dx over e to the x plus 2. Now, when I have a problem like this, I find the following formatting helpful for my solution. And you can use the same formatting if you want. So what I do, sometimes I find it, so if I just am working with one substitution, I usually write the substitution off to the side. You know, you should definitely, these steps you should write down, right? Otherwise you might get something wrong in the process. By the way, I was complaining that you shouldn't write the integral without dx. You start to see why we shouldn't write the integral without, what would happen if you didn't write integrals with dx and you're doing these calculations? What might you do? You might forget that you have to convert the dx to the du, right? That's the mistake I was talking about last class. That's why we must write dx, is because dx reminds us that we have to convert it to du, and then there's some scale factor that enters in depending on the substitution. Okay, so anyway, again, dx is something we should write. So what should I make my u substitution here, or what should I make my w substitution over here? Because I need different substitutions to do these different pieces. Right, that's kind of just like the one we just did, right? So this is du is minus 2x dx. If I solve for dx, we get what? Dx is equal to du over minus 2x for the first integral. Now the second integral, I get w equal to what? We're going to let w equal to e to the x plus 2 on this one. What's dw then if w is equal to e to the x plus 2? E to the x dx, right? So dw is e to the x dx. So we solve for dx on this one. We get dx is equal to dw divided by e to the x, right? Everybody on board with what we're doing? So now let's see if our substitutions were wise. So I usually draw some kind of dotted line here to illustrate that I'm connecting this equality, like so. And then I have the integral of what? X e to the u, and dx was du over minus 2x, right? Plus the integral of e to the x over w. Dx was what? Dx was dw over e to the x. Well, this is happy news. The x terms have canceled in both substitutions, right? So our u substitution and our w substitution was productive. They've left us with this integral of minus 1 over 2 times the integral of e to the u du, and then plus the integral of dw over w. Everybody with me? So then we integrate, right? So I've got minus 1/2 exponential of u plus the natural log of w. I mean absolute value of w, to be careful. Again, I'm not going to hold you to that on this test. So you can drop the absolute value if you want. I mean, whatever. Anyway, so minus 1/2, what was u? So minus 1/2 e to the minus x squared plus the natural log of, what was w? E to the x plus 2. Good news, e to the x plus 2 is always positive, so the absolute value bars are redundant anyway, so we can drop them. And there you go. I mean, what I was saying is, even if you were ignorant about the absolute value of e to the x plus 2 is just equal to e to the x plus 2 anyway, because e to the x is always positive. So an always positive number plus 2 is always bigger than 2. So certainly the absolute value of that's just the thing again. Is that? So the big idea here is to divide and conquer, right? I mean, there's two problems really written as one problem. So we have to pick it apart and do one piece at a time. I wouldn't advise trying to make one substitution for the whole thing. That would be. Go for it. Yep. Uh-huh. Oh. Well, see, there's some basic things that we're always using. First of all, the integral of u to the n du is equal to, now if you don't know these, you can't do this. I mean, that's true. Like, not knowing these will keep you from doing everything. So it's good the question you're asking, because not understanding that is a serious weakness. So first of all, this is known. This is the circle power rule for integration, or anti-differentiation if you like. The other one we know is that the integral of du over u is the natural log of the absolute value of u plus a constant. Again, I'm not going to hold your feet to the fire on the absolute value of this test. I'm just writing it because that's what's correct. And I was trying to avoid discussion of it altogether, but then stupid book rained on my parade. What was the other one we did? Oh yeah, sine. The integral of sine of theta d theta, right, is equal to minus cosine of theta plus a constant, right? No, I'm not allowed to show you that. We don't know. It's not allowed. It's not allowed. Man, there was something else. Oh, the other thing we knew. The only other thing we know is this. So these are your basic, at least for now, these are our basic antiderivatives that I mean, everything else is built from these and a substitution. That plus linearity, pulling out constants, that's pretty much all we got to work with at the moment. After the test, we'll learn another thing called integration by parts, and that will give us another technique to do some more integrals that we can't do at the moment. But That step is just, it's a basic fact that we're using, yeah. It's not something I'm deriving. It's just, it's an educated guess that we remember. These are educated guesses. Why are these true? It's because if you differentiate the thing on the right-hand side, you get back the integrand on the left-hand side in each one of these. Other questions? There must be other questions. Yes? Okay. Yes, this one. Now that is an improper rational function, right? It's a linear over a linear. So there are kind of two ways you could go here. Let's see here. So mine has 7 and t. Oh, they even give you a hint. If you don't mind, I'm going to ignore their hint. Excuse me. So pretty much, if you have division by something, odds are pretty good that whatever you're dividing by, you should make the u. So we'll let u will be equal to t plus 7. Then what's du? Yeah, that one's kind of easy. So we have integral of t du over u. If you come to something like this on the test, you don't know what you're doing, don't do crazy stuff like pull the t out of the integral. Just don't do it. I beg of you, do not do it. If you don't understand, face the difficulty. Figure it out. Okay? Don't just start making stuff up. It won't go well for you. You're like, do people do that? Oh yes. People do that. People make up all kinds of new integration rules for tests. What's fun is when they do that and accidentally get the right answer for the wrong reasons, right? And then you take off points and you're like, but I got the answer. Now here's what my colleague shows people to explain to them why that they still lose points. It's like this. He said it's like this. It's like 64 over 16, right? You cancel the 6's, you get 4. So should you count that? Should you count that right? No, you really shouldn't. It's like that. That's his go-to thing. I've heard him say it like 4 or 5 times now. It's hilarious. I like it. Yeah, cancel the 6's, get 4. That is wrong. Okay, and just to be clear, this is not correct. I mean it's very dangerous sometimes to tell jokes in a math class if they're taken the wrong way. It can be damaging. So you solve, basically the issue is to make the U-substution, you have to convert everything to the transformed variable. So I have to change the t to a u.
So what is it?
Right, t is equal to u minus 7. And that's exactly it that we have to do. So then you plug that in. So I got u minus 7 over u du. All right, now algebra. When we have a difference of things with a common, the denominator is the same on both terms, right? So I do have this law of algebra: a plus b over c is equal to a over c plus b over c. It does work that way. The thing you can't do is when the addition's in the denominator, you can't break it up. Okay. But anyway, that you can break up, so we got like u over u minus 7 over u du, which is really just the integral of 1 minus 7 divided by u du. I'm going to break it up into 2 pieces. That's the integral of du minus 7 times the integral of du over u. And what are these? What is the integral of du? I had a job interview once with a guy, and he told me it was his first test in calculus. Well, maybe the integration test in calculus 1. And on the test, he had put the integral of dx, and like 2/3 of the class got it wrong. So he brought in his grandson, who's like 5, and he put him in front of the test. He's like, son, what is the integral of dx? And he said, x plus a constant, sir. He's like, even my grandson can do this. What's wrong with you people? Sorry. I thought it was a funny story. So this is u. Minus 7 natural log of the absolute value of u plus a constant. So those are basic integrals. It goes back to our list of educated guesses that we must know over there. I'm sorry? So it's the integral of 1 times du, right? So it's the integral of u to the 0 power times du. So I do u to the 0 plus 1 over 0 plus 1 plus a constant, which is u. But the maybe the better answer to that is if I differentiate u with respect to u, I get 1. Like du to u is 1. So if you differentiate that, I get back to the integrand here, which is 1. But anyway, yeah. Anyway, it's good we had this discussion because this is something if I forget to mention and emphasize, there's a significant portion of people who will be like, I don't know what that is on the test, and then that won't happen this time though. Okay. Oh, and then we undo the u, right? So this is t plus 7 minus 7 times the natural log of the absolute value of t plus 7. Now I'll go look at the key again. I'm not sure if they're gonna be picky about the absolute value bars being there or not. In my answer, the absolute value bars are there in the key, so probably need to put the vertical bars for absolute value there. Actually, my answer, and this may be counted wrong, it shouldn't be counted wrong, but what could we do? What's another way you could write this answer? You could take this 7, right? And you could just lump it into the constant, and you could rewrite this as t minus 7 times the natural log of the absolute value of t plus 7 plus a different constant, say c2, where this c2 was just equal to, c plus 7. Anyway, the point is that these are two different antiderivatives, ignoring the constants, right? They're just two different antiderivatives for the same integrand. So both of those would be right answers, but WebAssign might be looking for the one I wrote in green, or the analog of it for your problem. By the way, that's what you'd get from their hint would lead you to that green answer. I mean, the hint basically is to go, hey, well, this is the integral of 1 minus 7 over t plus 7. Right. Right, and this gives us integral of dt minus 7 times the integral of du over u, and so you get t minus 7 natural log of the absolute value of t plus 7. Yeah. So that's how you follow the hint. Yeah.
Are you follow that with giving us a hint on the test?
I don't think I would give a hint on this problem. I think pretty much. If you had something like this, you should try the u being the denominator. If you do that, you can work it out, right? This is just like the square root problem we had last class too, right? This is very much analogous to that problem we worked. Something like square root of x times square root of, x times square root of x plus 2 or something like that. This is very similar to that problem. I mean, they're kind of the same idea, where we had to do that extra algebra step in order to remove the x, remember? Next question. Yep. Number 6 is kind of like number 7, but no. Well, no, I can do just one integral will work for number 6. Let's do that one. I'm going to erase this if that's okay. Yeah. problem 2? Okay, yeah, sure. All right. Let me move along here then. All right, what were we on? Number 6? So there we have the integral. I mean, I see why you'd think maybe we need to do 2, but this is another example of basically we make the thing in the denominator the u. I mean, that's not quite the case. It's part of the denominator we make the u. We don't make the whole denominator u. That wouldn't be a good idea. What do we want to make u in this problem? Indeed. Yeah, that's what we should do. Now look what happens if you do that. See, the thing that's super nice about that is when we calculate du, we get e to the x minus e to the minus x dx. So if you don't mind, I'm going to rewrite the problem like this. So, I mean, the thing in other words, the thing upstairs is really just what? See this? This is precisely what we have upstairs, right? So the substitution is that's du divided by u to the 5/2 power. Now I'm going to rewrite that because it's a good idea. This is u to the minus 5/2 power du, right? And now we use the power rule for integrals. So we do what? This is u to the minus 5/2 plus 1 divided by minus 5/2 plus 1 plus a constant, right? Now what is that? I do want you guys to do that kind of arithmetic. Please do not leave your answer minus 5/2 plus 1. This will make me sad if you do this. Minus 5/2 plus 1 is what? Minus 3/2, right? Yeah. So this is u to the minus 3/2. And so if we're dividing by minus 3/2, that's the same as multiplying by minus 2/3, right? Because the denominator of the denominator is the numerator again, right? Now that gives me minus 2/3, parentheses, what was my u? E to the x plus e to the minus x to the minus 3/2 power plus a constant, and there you go. Ugh. The kids brought home a cold, I think. So annoying. Ew. Where was I? Oh, number 2. Dose. All right. Here we face something like the integral of x to the 8th over. So there's a theme for today, which is look at whatever's in the denominator and pretty much choose part of that to be your u. This is another one of those. Number 2, homework 14. So, I think what we're going to do is let u equal to x to the 9th minus 6. Right? So what du will be what then? Very good. So I can solve for dx, right? Du over 9x to the 8th So what do I have? I have the integral of x to the 8th divided by the square root of u, and then dx was du divided by 9x to the 8th. Right? Yet again, we win. The x's cancel, right? Sorry, I should show you more examples of wrong U substitutions that don't work out, but I don't think it would be productive, actually. My advice to you, though, is if what you try doesn't work, don't give up, just try a different U. Right? Now, there's really not much opportunity for error. If you try something, as long as your algebra and differentiation is right, you've got a pretty decent shot at it, because there's really not many things to choose from the expressions you look at, right? Since you're not mathematicians and you don't, like, try to find ways to make it confusing, right? You just try to solve problems. I digress. Integral of du, let me write it this way. This is integral of u to the minus 1/2, right? Times, well, I'll bring the 1/9 outside, du. So that's 1/9 u to the 1/2 over 1/2 plus a constant. In other words, 2/9 times the square root of x to the 9th minus 6 plus a constant. And there you have it. So what, was there something in particular that was... No, that's just, I mean... There are a few moving parts here, right? I mean, we have to make sure we take the derivative right. If you, if you're not careful with the cancellation, you can get something wrong there. Integration, opposite of differentiation. I think the biggest mistake you guys tend to make at this point in the course is you confuse differentiation and integration. So you should try to make it firm in your mind which one's which, right? Differentiation takes something a power n down to something power n minus 1, right? Integration goes the opposite way. It raises the power of a power function. That's the difference. Yep.
Sorry, I have a question.
That's fine.
Where did you get the 1/2
Oh, that I'm using the first rule with n equals to minus 1/2. So minus 1/2 plus 1 is 1/2. So minus 1/2 plus 1 is 1/2. So 1/2 divided by 1/2, but division by 1/2 is the same as multiplication by 2. Because if you ask how many half pizza pies there are in a pizza pie, there are two halves of a pizza pie in a pizza pie. Sorry, I'm hungry. Anyway, so yeah, division by 1/2 gives you 2. That wasn't your question. This is just n equals to minus 1/2, right? Just that. It's not. Okay. Right. Yeah, minus 1/2 plus 1 equals 1/2 is the thing. Other questions? Yes.
Number 5 is what it's
Okay. I think we'll have done all of them. I think I'm only missing number 1. We'll have a complete collection. What were we on? Oh, 5. Number 5, right? This one's kind of a little bit different, actually. I'm glad you asked about this one. 5 e to the minus 1 over x divided by x squared. This is a good counterpoint to the examples we've been doing so far, because here's one where you don't make the denominator the u, despite the fact there's a denominator. So this one, there is something uglier than division. There's exponentiation, right? So that wins the contest of what's the ugliest thing. The ugliest thing, we make the input of the ugliest thing u usually. So the ugliest thing here is exponential, and so we make u equal to the input of the exponential, which is minus 1 over x. That's what we're going to do. Because with that substitution, this becomes nicer, right? It just becomes the integral of 5e to the u over x squared, right? And then there's the dx we'll figure out in a second, but that's better. E to the u, right? So what's du? So that's d dx of minus 1 over x, right? What is that, though? What's the derivative of 1 over x? Let me write it more suggestively. Minus x to the minus 1. Or tell you what, let me even write it this way. Du dx is equal to this, right? Which is what? It's x to the minus 2, right? Or to show the steps. Oh, I can erase that. I don't have to keep. I thought I'm out of room. I'm not out of room. I got plenty of room. So pull the minus out, right? Minus d dx of x to the minus 1, which is what? Minus 1 times minus x to the minus 2. In other words, it's 1 over x squared. Right? The derivative of minus 1 over x is 1 over x squared, is my point. Is it troubling? Oh, no, that's sorry, that's a remnant.
Is that from before?
Yeah, that was from the other one. Sorry. that one was from number 6. That's from number 6. That's part of number 6. Sorry about that. Yeah, no. Don't try to make that part of this. That would be very confusing. So the point is, once we see through the differentiation of minus 1 over x, we just have the du is, it's dx over x squared. Right? So therefore, dx is equal to x squared du. Which is pretty awesome, because then we can substitute that in, right? Plug that into the integral, and we get x squared times du. And what happens? The x squareds cancel, and we're left with 5 times the integral of e to the u du. Which is what? 5e to the u plus a constant, right? It's always one of those three things if we made the substitution right. And then what? We have to undo the, what's u? So this is 5e to the minus 1 over x plus a constant. And there, that's how you do it. Probably the hardest thing in this problem is the differentiation of minus 1 over x, right? Because there's something tricky about that. But does that make sense? How about this one? Now, if I was to ask this one on the test, here's one where I would suggest a U. I would give you hint. U equals to 1 over x. Let me show you how that goes. So this is the integral of, 1 over 1 plus 1 over x times dx over x squared. See, because x squared times 1 plus 1 over x, right, is equal to x squared plus x, right? So you can factor like that. And then this becomes the integral of minus du over 1 plus u. Because if u is equal to 1 over x, then du is minus dx over x squared. So, dx over x squared is equal to du. What? Yo! Yowzers. Goodness gracious. Anyway, and then you can make another substitution. This is the integral of minus dw over w for w equals to 1 plus u. And so you get minus the natural log of 1 plus u, the absolute value, plus a constant, which is minus the natural log of the absolute value of 1 plus 1 over x, plus a constant. Now, this problem is clearly a little bit harder than the homework problems. I would judge the difficulty of this problem about 30% more, maybe 40% more than your homework problems. I probably ask one question like this as a bonus question on the next test. Something like this. Something which is like your problems, but not one you've actually seen. Now, the required part of the test on integration will be very similar to the problems I've actually given you in homework, right? But anyway, other questions? Uh-huh.
When it's from the d over dx that's negative 1, I know how you got that, but when it's equal to negative 1 times negative x to the negative 2, how did you get the negative 2?
Oh, that's just the differentiation. That's this term. Is this term. So it's n equals to minus 1, right? So you have n x to the n minus 1 is minus 1 times x to the minus 1.
The derivative and the antiderivative?
No, the derivative. Derivative.
Oh, okay. I'm thinking antiderivative, adding.
Well, that's the thing, is we have to do some differentiation to do the substitution, yeah.
I mean,
Oh, okay. No, it's fine. Like I said, I think that's the tricky part in that problem. I mean, you have to be careful how you do that derivative. I think the biggest mistake people would tend to make is just a sign error, though. I mean, personally, I would sometimes make a sign error there when I was in your place. Of course, I don't make errors anymore, except on purpose to help your learning. It's a lie. Although now that I've told you that a lie, can you believe what I said? I don't know. If somebody tells you that they're a liar, I mean, what do you do with that? Guess you put them in Congress. I don't know. Let's see here. In what world are senators respected? We have this, like, senators are like, like it's a senator. And I fall into this trap sometimes, like thinking that a senator is something respectable, but they're not. They're really not. Look what they've done. Look what they refuse to stand up and defend. So many of them. Anyway. Now you have to disinfect that pencil. Other questions? Homework 12? I will allow it.
Can you do number 10 and number 11?
I can try. Homework. Now, although if it's a certain question, I will reject it.
Not one problem.
Number what?
10 or 11.
In homework.
Don't know how to do it, then there's-
Homework 12. Oh, so this is the x to the x plus 6 problem?
Yeah.
Number 10 and 11?
10 or 11.
10 or 11? I'll do 11. Although 10 is, well, I mean, we can do both. I'll take along. In terms of things I've done in class and things I haven't done in class, I hope when we have a review day Tuesday, we'll work some initial value problems. We haven't spent a lot of time on that, and it's something that definitely would be on the test, so I should probably make sure we do one of those Tuesday, just a note to myself. Okay, anyway, so here's, differentiate that. It's basically the question, find dy dx, right? And I think it tells us to do it by logarithmic differentiation, but it's kind of like, I don't have to say that because that's pretty much our only choice, you know? It's like, you know, here's a 100-meter pool, get to the other side by swimming. I mean, you know, what else are you going to do? I guess you could walk around the edge, but there's no edge here. Anyway, so the natural log of y is the natural log of x to the x plus 6. But then we use properties of logs, right? X plus 6 times the natural log of x. And then we're good, because we can differentiate both sides implicitly. So we'll do that. Differentiate implicitly with respect to x. So we get 1 over y dy dx is equal to d dx of x plus 6 times the natural log of x plus x plus 6 times d dx of the ln of x. That's the product rule, right? So what's the derivative of x plus 6? Yeah, this is just 1. And this is just 1 over x. So what I'm left with is 1 over y dy dx is equal to the natural log of x plus x plus 6 divided by x. And then you just solve for dy dx. So dy dx is equal to y times that stuff, which is x to the x plus 6 power times parentheses natural log of x plus x plus 6 divided by x. Yeah, number 11 said use logarithmic differentiation to calculate the derivative. It does do that. And the same is true for number 10, which I'll work here in a second. Number 10, same song and dance. Use logarithmic differentiation to find the derivative, find dy dx. Use log differentiation to calculate dy dx. Here we're given that y is equal to the square root of 3x plus 5 times 2x minus 5 to the 4th power. Again, the idea here is to take the natural log of the equation to make it simpler. The natural log converts products to sums. That's the beauty of it. So the natural log of y is what? How do you simplify this expression? So it's the natural log. Oh yeah, okay, so I'll get straight to it then, fine. Right. Exactly. Yeah. So you use the properties of logarithms to make that step. make sure you really, really own that step. You need to be totally confident about what you're doing there if you're going to be successful in logarithmic differentiation. It all goes back to the properties of logs that I presented the first thing. And then you differentiate with respect to x again, right? So I'll take d dx of the above. So I get 1 over y dy dx, right? Is equal to 1/2 times 3 divided by 3x plus 5 plus 4, parentheses, times 2 over 2x minus 5. So to get from here to here, I use this property, this identity, which is good to know. The natural log of u, if you differentiate it, it's du dx upstairs divided by u. That's the chain rule for the log function. I'm sorry? Well, almost. Then we should. Yeah, I got to solve for dy dx. So, if I could write it in terms of y, which I will allow on the test, okay? So the answer in terms of y is this. Oh, wait a minute. Never mind, sorry.
Oh, so we can just write the y for that?
Yeah. Yeah. Maybe not in the homework, though. It depends on the wording, I forget. But on the test, I will allow you to write y there. Save some writing, right? The explicit answer, which is more of a drag to write, is this: square root of 3x plus 5 times 2x minus 5. I will take either of these as answers, okay? The point is the differentiation has to be done. All right. So the thing I'm underlining in red is technically an implicit answer, whereas the answer to the right is an explicit answer. Explicit meaning it's just in terms of x. Well, I think that's probably it for today. Let's see what time it is.
And we'll have another review day on Tuesday?
Yep, Tuesday, just for your questions. So make sure you figure them out. Of course, we can talk about last year's test if you want to. That's fine, whatever. Thank you.
Thank you.